Hello again. So this video is just kind of wrapping up polynomials, and what we're going to do is just put together everything that we've learned so far about polynomials and just do a few calculations with them. Okay, but before we do that, I'd like to just review the concept of combining like terms. Sometimes it can be a bit tricky and not as straightforward as it originally seems. So I just wanted to do a quick review here. So in this little example, it asks us to circle or box all like terms. Remember that our like terms are terms with exactly the same variable parts and exactly the same exponents on those variables. So let's just take a look at this first term here. We've got an x cubed y squared. Okay, well if we look next door, right now we can't really even tell what we have, because you notice there's a parenthesis and an exponent around kind of the 3xy has a parenthesis. So we actually have to apply that power rule to everything inside here, right? So we should do that first so that we know exactly what we're looking at. So this is the same as 3 cubed times x cubed times y cubed. Okay, so this is going to give us a 27x cubed y cubed. So it's not the same as our first example here, because we have an x cubed y squared, and yet this one has y cubed. So this one's not the same as the first term. All right, for x, the x and the y just have a 1 as their exponent, so none of these so far are like terms. All right, so let's take a look here. So we've got a y squared x cubed. Well, let's see, the x has a cube, the y has a square, but they're not in the right order. Is that important? Do they have to be? Well, do you guys remember what the property is that tells us whether or not we can switch them around? Definitely can, can't we? This is the idea of commutative property, and it says that we can switch that x cubed and that y squared around if we want to, because remember that 1 times 2 is the same as 2 times 1, right? They're the same thing. So it looks like this term negative 7y squared x cubed is the same as the original. So we can definitely box those. All right, now looks like we've got this next term here. We've got one thing anyway that's not quite simplified. We have a 2 cubed. That's not quite as important in terms of combining like terms, at least at first. xy squared. This one has 1x and 2 y's. Not the same as anything so far that we've seen, right? And this one here has, this last term here has 3 x's and 3 y's. Let's see if we can find anything else. Aha! We have one here. Coefficients don't matter, right? We don't care about those until if we were actually asked to combine these, adding or subtracting them together, we could figure out how many x cubed y cubes we have. But in this particular example, as a review, all we're asked to do is box and circle ones that are the same. So we've got those two that are the same, the first and fourth are the same, and nothing else in that list is the same. Okay, so I wanted to review that because sometimes they can get a little tricky, and especially when you start throwing in so many terms, it can get a bit overwhelming. So you guys, on this worksheet, we're asked to just simplify, evaluate, and we're using the operations with polynomials. Where, like I said at the beginning of this video, we're just throwing in pretty much everything that we learned, and we're doing some calculations on some maybe a little bit more challenging problems. So I'm going to choose a few off of this worksheet to do. I'm going to start with number 1, which is asking us to evaluate. Okay, we're supposed to evaluate this expression. There's 2 expressions here, actually. We've got this parenthesis here, right? And then we have an addition sign and a parenthesis here. And we're asked to evaluate when a is equal to 1 and negative 1, and b is equal to negative 2. One of the things that I would always look for first is just look inside and make sure, I'm going to get rid of the blue here. Always look inside and make sure, is there anything inside these parentheses that we could simplify first? And you notice here we've got a squared b squared, a squared b, ab to the fourth, nothing there that can be combined, and nothing inside there. So, but I would always look for that, because if you can actually make, your life easier, your job easier later. Another suggestion I have for you is whenever you have a negative for the value that we are plugging in, make sure that you put a parenthesis around that. In case we have an exponent on there, we want to make sure that we notice that the negative 1 is included in that base. Okay, so when we're asked to evaluate, we're asked to plug in these values into our a and our b, whatever we see in our original expressions. And when we're asked to evaluate, in the end, we should come up with just one single number, right? Because if everything is that we're plugging in is a number, we're plugging in values for all of those variables, we will not have any variables left when we're done. So in the end, after we plug in these values, we should come down to just one single number. So if we were to kind of look at some steps here for what we're really doing, we could say that our job is to plug in our given values for the variables. And after we do that, we are going to be following PEMDAS, because everything's going to be a number. So we need to just be careful to follow the order of operations so that we can come down to our final solution in the end. Another strategy that I would definitely follow is to work directly underneath each, or let me start over with that, directly underneath the original polynomial, so that you're not working horizontally, you're not working all these steps out at the side and then trying to put them back together. Please just work right directly underneath. So here we have, and we notice here, the one thing we have to be clear about too is that we have an addition sign here. So it's one polynomial added to another polynomial. So these parentheses don't mean anything at this particular juncture, since we're just evaluating here. If this was a subtraction sign, we would have to multiply everything in that second parenthesis by a negative 1. All right, so I'm going to kind of pull to the left a little bit here so I can give myself some room. So 5a squared, well, a is negative 1. Put that in parentheses there. B is 2. Okay, plus, we've got another 5, and then we have an a again, so negative 1 squared times b, which is 2, plus 3. A is negative 1, b is 2. We're going to put that to the 4th power, plus 4 times a negative 1 to the 4th, minus 2 times negative 1 squared times b, which is 2. And lastly, plus 5 times a, which is negative 1, b, which is 2, and to the 4th power. Okay, you can see that's a lot of stuff going on there. So we have to be very, very careful with how we deal with this. I'm going to just zoom in just a teeny bit, give myself a bit more room here. Following PEMDAS, if I'm looking at this first parenthesis, or excuse me, these first terms here that are multiplied together right here, okay, before I get to this addition sign, I know that I need to deal with the exponents, because in PEMDAS, we know that we need to deal with exponents before we deal with multiplication, right? So we're going to have 5 times negative 1 squared. So I've got a negative times a negative, which is going to give me a positive, and 2 squared is 4. And I'm actually just working across in this manner. I'm actually going to be dealing with all of the exponents. That's all I'm doing in this step right here. So plus 5, and then I've got negative 1 quantity squared. Once again, negative times a negative is a positive, times 2. Okay, plus 3 times negative 1. I'm leaving that as is. I'm not doing anything with it yet. I'm going to actually just go to the exponent here. Okay, 2 to the 4th power, which is 16, plus 4, and then negative 1 to the 4th. So we have a negative base to an even power. Okay, and remember, that's not going to give us 4 or negative 4. It's always going to be a 1, either a positive or a negative, and in this case it's a 1. Negative 1 times negative 1 times negative 1 times negative 1. Okay, here we have 1 times 2 plus 5 times negative 1, and then once again 2 to the 4th power is 16. Now, this may seem like a lot of work to do this one step at a time like this according to PEMDAS, but please do that. Please do this. You will make a lot less errors, I promise you. All right, now that we've dealt with all of the exponents, we know that we can get on with the multiplication. So 5 times 1 times 4, which is just 5 times 4 basically, we've got 20, right? Plus, okay, so that's that. Here, basically have 10, right? 5 times 2 times 1 is 10. Okay, and then we've got plus here, but we have, you notice here, we've got a positive 3 times a negative 1 times a 16. So instead of me writing plus a negative number, I'm going to go back and change that to a minus sign because I don't want to deal with double negatives. Well, 3 times 16 is 48, and the negative 1 makes it the negative 48. And you notice a negative 48 just gives me a minus 48. So negative and minus can take the same place. Plus 4. Okay, now I'm all the way over here. Negative 2 times a positive 2, basically. I mean, a negative 4. And finally, I'm over here. I've got 5 times 16, which is 80. But I've got that negative 1, so I'm going to call that a minus 80. Wow, now that simplified very well, right? It looks a lot better. And I can go back and look and see what can I take out of here. I don't need these 4's anymore because plus 4 minus 4 gives me 0. So I'll just work left to right just so that I am dealing with the addition and subtraction in the right manner. 30 minus 48 minus 80. And 30 minus 48 is going to give me a negative 18, and minus 80 more. It's going to give me a negative 98. So you can see here from this beginning, wow, huge expression. We are left with one single number, which is negative 98. The other thing I want you guys to notice is if you will, please work vertically like I've said. You work downward, right? What you can see is that we end up with kind of this inverted triangle that comes down to our answer in the bottom. And that's what I would like you guys to kind of focus on, is working vertically, one step at a time. Make sure that you come down to your final solution, whether you're solving or whether you're just evaluating. Please get away from the habit of working horizontally and doing all this steps on the side. That's not really the algebraic process. That's more of a basic math method, and it really gets in your way, especially for those of you who are going to be moving on to pre-calculus or calculus. You will have problems that will go on for pages, literally pages, and you have to have that vertical process, one step underneath the other in order to be able to make sense and to be able to get to your final answer. Okay, so that's it for number 1. I'm going to move on to number 3. You can see the directions here for number 3 is simplify each sum. Okay, so let's move into this problem here. The reason I chose that is it has fractions in it, and I know fractions can make all of us panic a little bit. So I wanted to do this problem so that maybe we can take out some of the fear that definitely comes along with it. Okay, so let's just remind ourselves what we got going here. We've got a plus sign, so I know that my parentheses are not important, really. Not in terms of simplifying anyway. So when we're simplifying expressions, remember we're combining like terms. Okay, we're removing parentheses, which like we just said we don't need to worry about. So we're going to combine like terms. So let's find our terms here. Well, I've got an r to the first power, and it looks like I don't have any other r's to the first power. So I've got r to the fourth power here, and it looks like I have another r to the fourth power. So I definitely am going to be combining those guys together. And I've got an r cubed here, and that guy's going to be by himself because he doesn't have any other like terms that I will combine him with. Okay, so for right now, let's just start with the r. Let's just bring this guy down. And another thing that we normally do is when we have mixed numbers like this, we usually convert them to impropers. Once you get into higher level math, you really do, unless it's an application problem where you want to leave your final answer as a mixed number, we usually just convert everything to impropers because the calculations are a whole lot easier. So remember, we're just going to multiply the 6 times the 4 is 24 and add 5. So we're going to have 29 sixths r's. And then everything, or at least these are added. This is a positive, so we've got plus. And what I'm going to do is put these together because I'm going to have some work to do. I've got 1/7 r to the fourth plus another 3/8 r to the fourth. So those terms are the same. And then, whoops, I don't want that 2 1/4. I want to make sure I convert that to, right? So 2 times, 4 times 2 is 8. It's 9. And when we're doing that, remember we ignore that negative sign until we're done with the conversion. It doesn't come into play with the value at all until the end. All right, so one of the ways that we can kind of look at this middle here with the fraction, if it's helpful, you don't have to do this, but if it's helpful, what you can do is just keep the fraction part in the middle here, and you're kind of factoring out the variable at the end. You're going to say, I got this many of these guys, right? So you can kind of help to simplify that a little bit by separating them. And we know that we've got an addition of fractions, right? So we need to have common denominators here, don't we? All right, so looks like our least common multiple here is going to be 56. So we would just multiply both of them by the opposite, right? And then, of course, that's going to give us 8 plus 27. 21, what am I doing? Plus 21 over 56 of these same guys, right? So 29 56 r to the fourth. And I can bring these down for now and subtract 9/4 r to the third. But we don't really want to leave it exactly like this because we know that in algebra, we always write our terms in descending order of the exponents. So we're going to want to just rewrite this so that we make sure that we have everything in the correct order. So 29 over 56 r to the fourth minus 9/4 r cubed, since that is the next in the descending order. And then this is a positive, so we're going to write plus 29/6 r. So this is writing all of our terms in descending order, and we know that we don't have anything else to combine. All right, so that's it for number 3. And I want to jump to number 9. So I like number 9 because we actually have a few things going on here. I got a little bit more than just, adding or subtracting. What you notice here is we've got a combination of operations here. We've got this subtraction sign and an addition. So we're subtracting the first two polynomials from each other and then adding to the last one. Now we know with the addition signs that these parentheses don't really mean anything. So this is going to be fine just to list eventually, just as it is. But we know that with a subtraction sign here, this is the same as having a -1 out front. And when we multiply that -1 by both terms inside, it's going to change the sign. So I'm going to ask you guys to please take the time to do that, the middle step here like I'm planning to do. We also know this first parenthesis. I'm going to go back and just highlight that, kind of the same color. We know this doesn't matter. This one doesn't matter. There's nothing in front of it in terms of the parenthesis. So we can just drop that parenthesis without doing anything else. All right, so we've got 2xy squared minus x cubed. And I'm just going to do this in pink, so I want to just highlight kind of how it changes everything. So you can see we're just changing the sign of those terms on the inside. And then we can drop that parenthesis and just list these out. Okay, so remember when we're simplifying, first step is to remove parentheses. Second step, combine like terms. Okay, so let's see what we got here. See if there's anything that we can combine with each other here. We've got an xy squared. Do we have any other xy squareds? Actually, we do. We can look and see. So let's just, maybe we can highlight here, or maybe I'll just stick with boxing. So we've got the 2xy squared plus 3xy squared. There's no other xy squareds. Well, 2 plus 3 is 5. So I've got my 5xy squareds. That takes care of that. Next, I can see that I have some x cubed. Okay, let's just do some underlining. We'll do 2 lines under here. I've got a negative x cubed, and then I've got a positive 4x cubed, and I have a negative 2x cubed. I just jumped over that guy. All right, so remembering that this is a negative 1x cubed, so negative 1 minus another 2 gives me negative 3, and then we're going to add the 4 to it, which is just going to give me 1. So when we never really write the 1, we're just going to say plus x cubed. Okay, and finally, so we've gotten rid of those. Finally, we just have this minus 4xy sitting at the end there. And we are finished. Nothing else that we can combine. All right. Let's take a look finally at number 15. Now, the reason I chose number 15 is just to illustrate, first of all, what this is not. Remember, this is not something that we are distributing this power of 2 into. This is not, and the reason here is this addition sign. We can't do that, right? We could do this if everything inside was multiplied. Yes, this would be a power rule, and we would apply that exponent of 2 to everything inside. But since we have the addition sign in there, this is really saying instead, this is saying that the 5x plus 6x squared is our base, and the 2 is the exponent. So it's saying we need to take 2 of these. I'll go back to my black here. We've got our 5x plus 6x squared, and we're multiplying by itself. So we have got 2. We've got a binomial now times a binomial. Okay, and if we remember our rule for a binomial times a binomial, remember that we need to FOIL this, right? That is the method that we're going to be using. Okay, so remember that foiling is first, inner, outer, and last. So we're going to take this first term here, we're going to multiply it by the 5x. So 5x times 5x is going to give us 25x squared. And then we're going to take this 5x and we're going to multiply it by the 6x squared. So that's going to give us plus 30x cubed, right? Because this guy is to the first power and we always add the exponents on our same basis. Okay, then we're going to take the second term here. I can use a different color. Maybe that might be good. Let's try a blue. Okay, we've got our 6x squared and we're going to multiply that by the 5x. So we've got plus 30x cubed. And then we have the 6x squared times 6x squared. It's going to give us a positive 36x to the fourth. All right, so we have removed parentheses. Remember our rules. We're removing parentheses, and we did that using our FOIL method. Okay, and secondly, we always combine like terms. We'll get all of our ducks and geese together. So we're looking here at our exponents. I've got x squareds, x cubes. Okay, got some x cubes. Oh, and I've got x to the fourths here. Okay, so it looks like these two middle terms can actually be combined. So I've got 30 plus 30 is 60. And I'm going to want to write my final answer in descending order. So I'm going to move this 36x to the fourth in front. And then I'm going to have plus 60x cubed in the middle. And then finally 25x squared on the end. Okay, that is a finished product. Okay guys, I think that's it. There is an application problem and a bonus problem on here, but I'm going to let you guys work on that yourselves. And thank you so much. We will be talking to you soon.